Oh, hi everyone. Good morning. Hope my voice is audible to everyone.
Yes, we can hear you.
Yeah, yeah. Okay. Thank you. So let us start the session. Actually, we were waiting for a couple of more people. However, they are, keep on joining. Let them join. We will start in the meanwhile. Okay. So first of all, hope all of you are doing well. And we would like to welcome to our reputed VLSI DFT training and placement program demo session. We are very delighted to have each and every one of you here today as we embark on a journey of learning and growth. So, during this session, we aim to provide with you a comprehensive overview of our, success bridge training and placement program, highlighting its what is our training and placement program objectives, methodologies, and what would the skills you will acquire which will help you to kickstart your career or to enhance your technical skills for your career. So hopefully this demo session serves as a platform for everyone to experience the unique blend of expertise and innovation that our training program offers. So once again, everyone, welcome to our training and placement demo session. We are thrilled to have you here and look forward to productive and enlightening session. And one more request from our end is let us have this session very much interactive. Okay. So if you have any queries, please make a note and we'll have a Q&A session and Q&A session end of the demo session. So, so I would like to have more information. I would like, and I would request everyone to ask more questions with respect to your technical part or training or placements, or if you have any queries related to VLSI domain, everything, it should be very helpful for you and others as well. Okay, so let us start, and we'll start with a small introduction about success bridge. Then I will hand over the session to our trainer. Okay, so let me present my screen. Hope my screen is visible to everyone.
Yes.
Yes.
Yeah. So guys, as we told,
Yes, yes.
welcome to the Success Bridge. So, so about Success Bridge, it was founded and managed by the industry experts in a decade experience in the industry, who are the veterans of industry in VLSI and IT infrastructure. Okay. So we have our trainings are aligned with the company, the best VLSA software and training programs, which basically address the current gaps in the industry. Gap in the sense, obviously, you might be knowing there would be a gap from academia to corporate. So this gap, this success beats, yes, we are trying to fulfill that gap. Okay, yeah. So this is our vision. We are basically we have started to we wanted to be a recognized leader in the industry. How it will happen? By providing the knowledge, skills, and confidence, empowering individuals and as well as the corporate everyone. That will help everyone to get success in the rapidly changing world. So to reach our vision, what is our mission? So we would like to provide high quality, user friendly training services that enhance productivity, efficiency, and we aim to cultivate a diverse and collaboration with and respect and integrity. So these are our training programs, training and placement programs. In VLSA, we have front-end design verification, DFT, physical design, analog layout, and in IT we have IT infrastructure, something also called IMS, infrastructure management service, managed services. So this is our curriculum. Actually, I don't want to take much more time because we have our main content of demo session. So I'll just take you through the very quick. So this is a design verification, or this is a design verification curriculum where we'll cover digital design. So in our VLSI trainings, digital logic design concept is pretty much included for everyone. Either it is a design verification or physical design, analog layout or DFT. So we will cover a digital logic design basic concept, whichever is required for an respective domain. So here we'll cover introduction to HDL, VHDL, Verilog concepts, system Verilog, and test plan creation, UVM, and functional coverage closure. So so DFT. 1 minute, guys. So today we are here for this DFT training and placement program. So we here what we cover, as I told, we basically cover digital logic design, which is an part of our training, and along with that, introduction to DFT, ASIC flow, boundary scan, understanding of scan in depth. We have JTAG operation, ATP and simulations, basics of LBIS and FBIS technologies, and basics of scripting languages. So for physical design and this DFT, right, we may need some sort of scripting language. So whatever is required, that will be taught to you. So physical design, so introduction to PD, synthesis, floor plan, power plan, placement, CTS routing, and we cover IR and STA PV as well. So this is for analog layout, and we'll just take you for in IT infrastructure. We basically cover hardware networking, Windows administration, Linux administration, VMware, and in cloud we cover Amazon Web Services and Microsoft Azure. Okay, so in IT infrastructure we have something called IT or on-job IT enabled program, which is totally unique you cover compared to other institutions or other training companies, where you'll be working on the real-time experience. Okay, so along with this technical part, so we are covering something called soft skills, which is pretty much required. So once, because the people who is coming from the colleges, they might be from the rural areas or different colleges, which may not concentrate more on the soft skills. But even though you are good in technical, if you are not able to communicate properly, then your technical skills won't be considered. So that's the reason we work and we focus on to the soft skills part also. So which includes communication skills, personality development, presentation skills. Presentation in the sense, we will give you the individual and group presentations, which will help you to come out of the stage fear and much more things. So public speaking, email writing and etiquette, and interview skills and more. Okay. So how the selection process will happen? So you have to apply on our website, and we have now you can interact us directly over the call also. So then once somebody has applied, then your application will be screening. Screening in the sense, what is the qualification, what was the percentage or aggregate, because we basically looking for the people who have minimum more than 60 percentage, that will not impact the placements, that will helpful for the placements. So then you'll have the discussion with our technical or HR discussion, so to know how the communication part and then admission part will be there. So guys, this is one of our main important slide. So what is the specification? What is the uniqueness? Why you wanted to join a Success Bridge? Okay, because there are many more training institutions who have more than a decade or more than 8-10 years of experience. So what is the unique? Because there would be something which you wanted to choose, right? So I would like to highlight a couple of things here. The first one, the trainers. The trainers with whom we are working, they are the real-time employees. They are not the teachers, the professors, and lecturers. So the current trainer of the Mr. Asad, who is going to handle the session, I mean entire training part, who has he has more than 12 13 years of work experience, currently working with one of the product-based companies. Okay, so you can just look out how the real-time experience trainer experience is going to help you to kickstart or enhance your technical skills. So the next one is industry standard tools. So we are using the Synopsys EDS Synopsys tools. So for DFT, I think we have a Tiger server. So we will be working on the real-time scenarios. Okay, these are not the crack version. These are the real-time license tools. Then you will be having the projects. So you'll work on minimum two projects, which will be helpful, and that can be that will give value to your resumes. So then module wise assignments. So what are the modules I told you, right, for a DFT training? So after completion of each and every module, you will be having the assignments. And this time we are planning to have the mock interviews for each and every module as well. So where trainer will take up the mock interviews and he will give you where you need to come improve yourself. So that will help us not to no need to wait end of the entire training. After every completion of every module or domain, you can go ahead. Then, as I told you, right, we have something called soft skills and communication sessions. And maximum head count of each and every batch will be 15 students, not more than that. So this will help us to give the individual focus, and placements also very, very much easy for us. So mock interviews by industry experts. Sorry. So as we told, module-wise assignments will be taken care by module-wise mock interviews will be from by your own trainer itself. So after completion of the mock interview of the entire module or entire training part, your trainer will take up the mock interview and either minimum one mock interview from the industry other experts also. So which will help you to understand what is the market requirement, where you need to brush up yourself. These things will be, and trainers will give you the feedback where you need to improve yourself. So as I told, since we have maximum head count of 15 students, so that will help us to give the individual focus and flexible timings. As we told, our trainings are online trainings. So this will be planned every day in between evening 7 to 9. These are the live sessions, guys, not the pre-recorded sessions. So where you will be interacting with your trainer every day directly. And for the revision or revise part, you will be having, okay, uh, recording sessions. So if you miss out, for example, if you miss out any one or two sessions, you can revise it. Okay. So, and also the affordable fee. So coming to the fee part, if you look it out in VLSI, the tools trainer part is very costly. So to make it very much like inflexible or to make it everyone feasible, so our online training fee was supposed to be 85K including GST and everything, but now even in that also we are providing the discount. So including your GST and everything, you have to pay only 70K. So 10K as a registration fee, remaining that can be paid in couple of installments. So let me call it again. For this online VLSI DFT training and placement program, the fee is going to be 70K. Okay. So in which you have to pay 10K as a registration and remaining couple of installments. So as I already told, we already got couple of more than 8 to 10 registrations, and we'll go for minimum only 15 registrations. So whoever is interested, I would request to do the registrations after the demo session. So the next one, the last but not least, and the main part, the placement support till everyone get placed. So the main motto, end of the thing, people wanted to have and get hired for the placement part, right? So we will support the people till they get placed, because sometimes the placement will happen immediately. Sometimes placement will happen before the company delayed. but we will support you everyone till they get placed. So whatever the support is required, that will be provided. Okay. Yeah, these are our partners. So in ED partners, we have a synopsis, as I told you, for our all our DFT, sorry, VLSI training. We have our synopsis as a tool, and the placement partner. So we have NSEMI is one of our own service company. So along with that, we are signed MOUs with couple of companies like Wipro. We have signed the MOU for the placement, and like such, our people have got placed in SIGPT and in semi. Okay, and we are in empanelment process with big service-based companies as well, with the packages of minimum, I mean to say, 4.5 to 12 lakhs. Okay, as in freshers. So this is our contact. This one. So if you wanted, you can reach out us on info@successbiz.co.in. Our website successbiz.co.in. These are contact numbers, and we are located in Koramangal, and we have office in BTM as well. Okay, so thank you guys. So yeah, any queries till date as of now?
Sir, course duration?
Yeah. So this course will go for a minimum 4 months. Okay. So this includes your theory, practical, and the projects which will be calculated. Okay. And guys, we in every batch we have people as a freshers, and we have people who wanted to start their career from the different domains. We have people from the academia background. Okay, because as you know, the current semiconductor industry is booming like anything. Okay. So and one more thing is, you people are really glad that in semiconductor industry, not like IT. In IT, irrespective of domain, anyone can join. Anyone, for example, even a non-technical person can start his career in IT. But in semiconductor industry, it's not like that. Companies will look out for people who have ECE, triple EI, electrical, electronic background people. So it's like this is very good uh, this is going to be a very good opportunity for you guys to start. As you guys know, even recently our government of India also started a much more activities, or I can say they're have planning more things for the semiconductor in our India itself. Okay. So guys, before I would like to give session to this trainer. Anyone any queries as of? Okay. So guys, and one more thing I would like to say, please be as I told you, right? Please make the session as much as interactive, and make a note of the questions. If we have anything any questions, we can make it out. Okay. And please be with us till till the end of session. And also, guys, there is a Google form mentioned in the chat box. Okay. So I would ask everyone, I would like to inform everyone to please fill the form, so that we would be keep you informed with our upcoming trainings and other things. Mr. Nagaraja and Bas has raised the hands. Do you have anything to ask?
So can you share the slides of those who are placed from this institute in the previous month, not the
Yeah, yeah, we
previous
can do
year?
it. We can share it.
Okay.
Okay. See, so coming to the placement part, couple of our people have attended Wipro and Insemi, and couple of more companies which are as of now they are able to get this one. Other placement part, you can look it in the website as well. Anyhow, within some time we can share those details also over the call itself. Okay. Yeah. So Mr. Asad sorry, Mr. Ahmed.
Yeah. Hi.
Yeah.
Hey.
So guys, let me introduce the trainer. as I told you, right, we are glad to have Mr. Ahmed on our call, and he's going to take up the entire training part. So he has more than 12 years of work experience in VLSI DFT domain. Okay, and he's currently he worked with multiple service product-based companies. Now he's currently working with one of the big MNC and a product-based company. Okay, so yeah, Ahmed, please go ahead.
Okay. Thanks, Shaikh, for your introduction and brief overview of Success Bridge. Okay. Let me quickly share my screen to go through some of the technical parts that I have to share with the audience so that they can have a very good visibility on what we are going to train in the training session. Just give me a second. So is my screen visible to everyone?
Yes.
Okay, that's good. Let me take it to the presentation mode. Okay, basically, I will be the trainer for your DFT training session, and I have been doing this training for last few training session as well. So most probably this will be my third training batch, and I I have been working as the Shaikh mentioned. I have more than 12 years of experience for this particular domain, and I have worked on multiple chips. Which actually has now in production. So how this DFT or design for testability actually works on our chips, that one I will try to briefly explain because it's a very huge topic that cannot be covered here. But I want to give you some highlight. But I will try to give more information regarding that. What is the scope of your career if you choose DFT as in career path? So what will be your opportunity? What is the current industry requirement? Whether this domain is a very high demand or not? What will be the salary? So that kind of information I will try to give you more insight so that you can make some decision to adapt this training session and move forward with your careers. Okay, so these are the few topics that I'm going to discuss with you. Introduction to trainer. I think you have already got my introduction. The next topic will be the basic overview of IC design flow and the DFT. And then we'll talk about the EDA. EDA means electronic design automation tool for the DFT. What are the tools that we will be going to use? And then scan insertion principle, semiconductor industry overview, how the ecosystem actually works, and where do we actually play the role as a DFT engineer. And then we'll talk about the career opportunities for the DFT engineers. And then I will give some brief overview that what are the training curriculums that we have right now to give you the training for to prepare yourself for your career. Okay. So this is a very important slide, although it has a lot of information. We will not be able to explain each of every term, but I want to give you some high-level overview that how the design steps for an IC design happens. So it's a very lengthy process, and it will have a multiple steps for the design. So here are a few steps that I have mentioned. The chip design start from the system specification. That means the system specification is something like this. Whenever any company they want to manufacture any kind of chips, they have to communicate with their client. So what is the requirement of a client? Let's say now is an era of AI, artificial intelligence. So all the server, all the latest CPU, GPU, those kind of electronic device that we are going to use, the same customer is trying to incorporate the AI in their design. Like now you are using a iPhone. So iPhone, they are trying to optimize it. They are trying to see how they can meet the latest requirement of their customer. So from the design perspective, they have already some kind of design, but the customer is asking, okay, we want AI, artificial intelligence in our chips. That's where the system specification, all those architecture of the chip, they are very high level people around more than 30, 40 years experience. They discuss with the client what is the requirement. Based on their requirement, they try to make some kind of specification or architecture definition of your chips. That's why the first stage happen. What kind of chip we are want to design? Let's say you want to design one kind of chip that will use the existing design, but it will have some kind of modification to incorporate the artificial intelligence feature that the client actually wants to do. So after doing a several round of discussion with the clients and the architecture, they decide to do some kind of, they come up with a final architecture definition. That is what we call as architectural design. So it takes significant time because there will be a lot of discussion happening between the customer and versus the actual engineering team that is going to design these chips. So after we came up with some kind of architectural specification that, okay, this is something we want to build and this is something the customer actually agrees, they have signed the contract with us. So the next step is to do the functional design and logic design. That means the specification is some kind of what features we want to incorporate, like artificial intelligence. But in the functional design, that is what we sometimes call as the RTL design. So in that RTL design, they will try to do the logic design to meet your customer requirement, customer specification. So after the RTL design completes, it also takes a lot of time because RTL design, they try to see optimize, how can we optimize the design, because the same thing can be written in a different way, but we need the most optimized way because we want to give the best design to the customer. So after the RTL design, they complete their design, there will be another step that is called the design verification. These are the name of the keywords. Probably if you look into the LinkedIn or a lot of requirement, you will see that RTL design engineer. Some people is hiring, some people is hiring functional verification engineer. So they are actually playing a role here. So after the RTL designer complete the RTL design, they will hand over the design to the functional verification team. They have some kind of test bench, they have some other setup to verify the functionality, whether the specification has been correctly done during the RTL design or not. That kind of verification they will be doing. So this part we call as a front-end design. The RTL design and the functional verification is called a front-end verification or front-end design. So after we complete our front-end design, then once they complete, okay, the design is good and it is also meeting the functional requirement, let's give it to the back-end team. There is another technical term, back-end team. Back-end team, what is the purpose of that team? They will take the RTL. RTL is a logic design. They will convert it to the logical gate. Like in our undergrad, we have already familiar with the VLSI course. We are familiar with the AND gate, OR gate. So these are the logical gates. So the RTL that will be converted to the logical representation with the AND gate, OR gate, this kind of things. So who will going to do that kind of things? That is what we call as a back-end design. And mainly that will be done by the physical design team. That's why you also see sometimes people also looking for, we need a lot of physical design engineer. That is also one kind of domain expert. So this backend team, physical design is the frontier. They will be mainly taking the RTL from the front-end design. But with the DFT engineers, we will be closely working with the physical design team. And together we call as the backend team. So the backend team, it consists of physical design team, which is a very big team. And they will also have the DFT engineers. which is comparatively a small team because physical design, let's say in your team you have total 30 physical design team, but compared to you will not have 30 DFT engineer teams because the ratio is not like this. Physical design teams has more jobs to do. They have a lot of steps. So for every block, let's say in your chip there are 30 blocks, then they usually maintain 30 physical design team to complete the whole chip. But for the same chip, maybe the ratio is 1:3. We need only 10 DFT engineers to do the job because in our DFT part, we have a different kind of jobs, but one people can handle 3 blocks. So that's why usually the physical design team compared to physical design team, the DFT team will have less number of headcounts. But the DFT team will will actually do a lot of things. They have a very crucial role to make sure the design has a appropriate DFT structural design incorporated. Because you can see that there is another step called physical verification and sign off. So once the physical design team complete the physical design, they do the chip. This is called a tape out. You will also have this kind of name, tape out. Tape out means they have completed the design. That design is ready for fabrication. So that's the process. The silicon will be manufactured here. So after the fabrication, once the chip comes, it will come for packaging and testing. You see the testing. So the physical design team has already been done after they tape out. But we DFT engineer, we are still not done yet. Because whatever DFT architecture we have placed inside the design and whatever test pattern we have generated, that is needed to be verified on real silicon. That is called we have to verify it on the ATE. So as a DFT engineer, you have a very high demand, even if the design has been taped out, but you still need they need you to complete the testing part as well. That's why the scope of DFT engineers in the whole manufacturing process of a chip, you can see you will play a very vital role during the design phase. So this is called the design phase, pre-silicon. And even after post-silicon, you also have a very important role to play. So the job opportunity or the job requirement, you will have a lot of opportunity. You don't need to be worried about whether I will lose my job or how is my scope of job. As long as you are a very qualified DFT engineer, then you don't need to be think of your job security. It's a very highly secured job. And not every people can do this kind of, like when the silicon comes and it is tested on the ATE, not every people is very efficient to do the silicon debug. So if you can adopt that kind of knowledge, then you are exceptional and you will be very highly paid engineer. So you can see the physical, just now I give an example, right? The physical design team, they have total 30 people handling one block. But compared to the physical design team, they have 1:3, consider, let's say they have 10 DFT engineers. So sometimes you might heard some company do some kind of layoff. They just sack some peoples. But in that scenario, you will have very less risk because they will choose, okay, I have physical design team 30 people. I can optimize some people. I can lay off from here first because I can assign maybe now 1 block per person. I can assign 2 block per person. So I can optimize 10 people from here. DFT is already been less. So I don't need to be cut down from the DFT engineers because they are already needed. Even I need from after testing as well. So even the company will not think to lay off the DFT engineers job because they need their engineers. So as long as if you can prove yourself a very good DFT engineers, then I would say from job security perspective, it's a highly secure job and it's also a very highly demandable as well. Because not kind of every people doesn't have this kind of debug. When the silicon comes on the ATE, it needs a very manual debug effort, which is a very specialized, uh, I would say specialized, um, um, your what do you say, um, qualification. But during this physical design, all those things, these are highly automated flow, meaning we will use a lot of EDA tool. So EDA tool will do a lot of jobs. So you don't have that much enough to do, enough to contribute, because the EDA tool is already smart enough to do a lot of job. So you just need to check the report, all those things. So it's something like kind of, if you don't put enough effort, if you don't put enough effort to put yourself as a very good position, then it's a very high risky position that you can get lay off by the company. But for a DFT engineers, since you have a lot of manual activity here, and that is something that the tool cannot do, so definitely they need human beings to do that kind of jobs. So that's why you can secure your job very well. You don't need to think of it. Anyways, this is something that I just wanted to give you some overview that where you are actually playing a role, where is your scope of job, and how secure this job as a DFT engineer. But over the time, once you start to working on that, if you feel more interest, then you will feel that, okay, I'm on the right track, so I'm doing very good, very good. Anyways, I think this is the first slide that just give you some overview of the whole chip design process. But since our training focus will be mainly on the DFT part, so in the next slide, I want to give you some more insight about what is actually DFT, or what we are actually trying to achieve in the design. So let's say this is your chip design. You can see in the chip, you will have some kind of inputs that will be driven by the tester, or that will be driven uh, by the outside world. It will have some output that will be measured in the outside. Inside the chip, there will be some kind of logic. This logic is just a logic gate, AND gate, OR gate. There are different kind of combinational gates there. That is what you have learned into the VLSI basic course, right? You have learned the combinational gates, AND gates, OR gates. Then you have learned some sequential gate, which is called the flip-flop. So these are the flip-flop and these are the logic gates. So this representation is called the logical representation of the RTL code. So the RTL is written by the front-end RTL designer. And this gate representation has been done by the physical design team. That is called the netlist, gate level netlist. So once they convert this gate level netlist, then they will give this netlist to the DFT engineers to put the DFT architecture to make sure they can test this logic, whether there is any functional fault or not. So that's where our job starts. So if I give you some high level overview of our DFT flow, it's not that every company will follow like this one. It's just a it's just a sorry. It's just a briefly overview that this is something we usually follow the flow. So in this flow, you can see we have already talked about the verify of functionality. This is the create of the initial design, that is an RTL design. Then you will do the verification. After you verification, we can insert some kind of DFT circuitry into the RTL stage. This is possible, but it depends on how the customer actually asks. But we can also build in self circuitry. That means this kind of testing circuitry will enable you to test the circuit automatically. Now, probably you have already familiar with the Tesla, right? Tesla is an automotive car. So how this automotive car actually, let's say when you are driving the Tesla, it has the self-driving mode. So you can put it into the self-driving mode, then you don't have to do anything. It will take care of everything. So it's just an example, but whatever an automotive device. So whenever you start the Tesla, it do some kind of routine checkup to make sure its automotive system is functioning correctly, right? Because you cannot fully rely on Tesla automotive features, because it is a device, it is an electronic device. It can have defect. So definitely there should be any, every time when you start the Tesla engine, it will do some kind of auto check to make sure its braking system is working fine. There is no abnormality there. If there is anything, then it will flag. It will give some kind of red alert that something is not good. Its sensor system is working fine. All those basic things that is needed, it will do the auto testing on the field itself. So how does this thing actually do what we call as the built-in self circuitry? So as a DFT engineer, we also put that one. So you can see where you are actually contributing and how your work is being reflected in real life uh, product. Then we will have do some kind of boundary scan. Boundary scan means, let's say you have to test this design, right? So if you want to test this design, first you have to make sure the inputs and outputs, they are defect free. In order to test the inputs and outputs, we insert one kind of DFT circuitry, that is what we call as the boundary scan. Then the remaining portion is the internal logic. In order to do the internal logic testing, we put some kind of internal scan circuitry to make sure we cover all the part of the chip that has been tested properly. So in order to cover all this part of the chip, we put some kind of DFT circuitry, boundary scan or internal scan circuitry. But using that scan circuitry, we generate some kind of test pattern. That test pattern actually applied on the ATE. When the real silicon comes, they apply the test pattern to make sure the silicon is actually working as what it has been designed during the pre-silicon stage. That's why we generate this generate and verify test pattern. Once we actually generate this kind of pattern and verify it, then we hand over this pattern to the customer. Maybe that customer, they ask, okay, generate the pattern, give us to us. We'll run on the ATE. Then it should be fine. It's a very good handoff. Anyways, this flow actually is a very high level. I try to explain as much as possible, but we'll have a very, very detailed discussion on each and every topic during our training module session. So you will learn very basic things and you will clear your concept to make sure you can be a very good DFT engineers. Okay, now let's talk about this part. It's a very important, DFT tools, because you know the designs are a very big design. It's a multi-million gate design. You cannot do everything in your hand. You have to take the help of electronic design automation tool. That is what we call as a EDA tool. So these are the three industry leading tool that has been using multiple projects across different clients. So they are well competed on each other. So one is the tool coming from the Siemens Tessent tool. The name of the tool is Tessent. The name of the company is Siemens. Then another company is Synopsys. Tool name is TestMax tool. Then Cadence. Tool name is Modas Test Solution. So all these three tools are industry standard. They are very competitive. And if you can adopt any of the tool, you can actually handle the remaining tool as well. Not necessarily that they have a very, very big difference. They have a very pretty similarity. So if you adapt one tool, apply your knowledge, if you work in another project using a different tool, you can still be able to do it properly. Then you don't need to be worried about it. So for our training purpose, we have a collaboration with the Synopsys. So we'll be using the Synopsys TestMax tool. It's a very, very good tool. A lot of project, a lot of chip is using the Synopsys DFT architecture. So it will be a very good start point for you to adopt this tool. And I hope this will give a very good bonus point for you when we apply in any job. They will definitely prefer the Synopsys tool. Is a very, very high demandable tool. Okay, so now I want to give you some more in-depth technical details so that you can understand that what are the jobs actually you are going to do. It is a lot of things that will be happen, but I want to give you some very basic things that is your focused. So whatever I'm going to discuss, it will be your primary job, the focused item. Then all other activity that you are going to do is to achieve this. This is what you have to achieve as a DFT engineer. So what actually have to achieve? So the thing is that the DFT engineer, the main role is that the chip will be manufactured. So after the manufacture, how can we ensure that there is no manufacturing defect inside the tool? So this is the problem statement from the chip design perspective. After manufacturing, how can we ensure there is no defect inside the chip before we hand over the chip to the customer? Like you buy an iPhone because you are very happy with the iPhone, it's very smooth, it doesn't malfunction, you have been using it very. So iPhone has been able to get the trust from the customer because of high quality of testing to make sure all the chips inside the iPhone is very functioning. But sometimes you will see that there are some other phones in the market, but people is not buying that much because after using 1 or 2 years, they will be very slow, they will be malfunctioning, they will be very heat up. So that kind of a lot of claim is coming, right? Because the chip quality is not that much. Probably they have a lot of defect inside that will be exposed when you start to use it for a long time, right? So you are the engineers that actually going to qualify the quality of the chips. Like those people is actually working on the iPhone DFT part. They are very proud because they know that whatever DFT architecture they have implemented inside the chip and how they have generated the pattern to make sure the chips are well working. Now people and customer are happy. They are making queue for the latest iPhone. So that's the very um, uh, moment of proud that you have been doing a very good job that is being recognized by the customer. So as a DFT engineer, you can see it. The other engineer, functional RTL, definitely they have a very good playing role. But ultimately, the qualification of the chip depends on you. If you generate a very poor quality of test pattern, that makes, okay, the chip is functioning, but the chip out of 1000 chip, 500 is functioning, 500 is malfunctioning. That the yield is very low. So the RTL designer is also okay because the 500 chip is working fine. Physical design team is also okay because they say 500 is also okay. Then what's the problem? The problem is with the DFT engineers. Maybe they haven't done it properly. Their pattern is very good, not that much quality. That's why they are not able to catch all the defect that is happening during the manufacturing process. So the RTL design, the physical design, they don't have anything to do to solve this issue. Only the DFT engineers can solve this issue. They will work on the ATE, they will gather the silicon data, they will analyze it, then figure out that why the manufacturing is happening, why we are not able to catch it. Anyways, so the most useful technical terms that as a DFT engineer we will be using, which we will call as a defect. What is the defect? The defect is some kind of things that will happen during the manufacturing process. You see, the manufacturing process will have a lot of steps. It will have lithography, real silicon, then it will work on the transistor level. So it's a very huge process. So that process cannot be 100% defect free. Maybe even a single dust can go inside. That's why you see the fabrication, they call it as a clean room. Clean room means it has to be almost 100% pure because a single dust can cause the chip to be defective. So we can assume like this, that in manufacturing process, somehow a single dust has been inside the chip and this dust will cause a shortening between the two adjacent wires. These are the two wires. So this is something happening on the real silicon. Then how can we actually model this into the pre-silicon? You see that there are two stages. One is the silicon, pre-silicon, which is we call as a design phase. One is after silicon, after fabrication, that is a post-silicon. So the defect will introduce into the post-silicon stage. But as a DFT engineer, you have to think of that how can we model that scenario into the pre-silicon stage, because I will be working on pre-silicon. I have to provide the solution into the pre-silicon. I have to incorporate that solution inside the design before it manufactured, so that I can detect it after manufacturing. So that's why we model this defect as a fault. This is our technical terms, fault, meaning there is a short between these two nets. Maybe one is the signal net, one is the ground net. Then we can model this, that this net is actually driving one of the logic gate, and unfortunately one of the net is being grounded. That is what we call as the fault modeling. And this fault modeling, we give it as a name. That is what we call as a stack at fault, because it is stack at to the ground. Stack at zero, ground is zero. That's why we call it stack at zero fault has been introduced. Then based on this fault model, we will try to provide our ATPG pattern. ATPG pattern will be generated based on this fault model. We will have the scan circuitry to detect this kind of fault. That is will be our detailed discussion in our technical session. But I hope this particular slide is just to give you the basic insight that what is the objective of a DFT engineer. This is something you have to achieve. Whatever you do, ultimately you have to think of something will happen in manufacturing process, I have to detect it. That's my job. And how will I detect it? That's your engineering skill that you have to develop. So now example of defect. Just now we talk about that everything starts from the defect, right? So how this defect can be introduced during the manufacturing process? So it can be happen the material, the silicon that
Ahmed bhai,
we're using. Yeah.
my suggestion, let us not go much more to the technical part.
Yeah, I think I have on this slide, then I will go to the
Okay,
more
fine.
oriented, because I just
Okay.
want to give overview. I don't have that much slide.
Yeah, okay.
Okay, so for the defect part, as I already mentioned, it can happen on silicon. The silicon itself can be is a material. That is what we call as a material. The itself, the silicon can be a poor quality that can introduce the defect. But let's think that the silicon is a very high quality silicon. Then when the silicon it start for the wafer fabrication process, then a lot of steps happening, masking, lithography, ion implantation. Every step it can have some kind of issue. It can have some kind of defect. It can be introduced. Even the wafer fabrication process, if it is very good, then the wafer it goes to the packaging. That packaging process can also be have some issue. Even after packaging, when you start to use that device, let's say if you buy a mobile, it cannot be last for forever. After 3-4 years, it will start to degrade performance, because over the time, if you use, the silicon behavior will change. So it will introduce some kind of defect. Anyways, so these are the few things that will happen. We'll have more discussion on details on each of these during our DFT, because we have to understand this properly. Anyways, so this is something I have already been discussed. So I just wanted to quickly overview on this particular slide. This is I will not take that much, because this is something is very much technical, but it will also give you a very quick understanding that what we are actually trying to do. Just now we talk about the logic, right? This is your combinational logic, and this is your flip-flop. So you have to test the logic inside here, and how you actually do the testing. That is what we call as a scan insertion. As a DFT engineer, we build some kind of scan circuitry to make sure we are capable of do some kind of testing. So that's why we build. You can see the red line. This red line is called scan chain, which is a very popular term for the DFT engineers. So this scan chain circuitry we build, our tool can build it based on our specification. And this scan chain will help us to detect any kind of fault. Just now we talk about like there is a stack fault happening here. We have modeled it. So if that kind of fault happen here, what kind of test pattern? Test pattern means what are the value you have to put into the primary input to make sure this fault can be detected. Detected means, let's say if there is no fault, then what will be the response of the circuitry? 1 is a green. This is called a fault-free response. But if there is a fault happening here, then a faulty behavior, that means it is stuck at 0, right? So it will not give you response 1, it will be 0. So that's the difference. Fault-free condition, faulty condition. The ATE can detect this difference, and then it will flag out that this device is defective. So that's why this slide actually gives you that this kind of scan circuitry we will be building as a DFT engineer to make sure any kind of fault happening in any of the node is able to be detectable on the ATE. That's our main thing. Okay, so we'll be discussing more insight. If you have interest on this, if you think that DFT is a very good, I feel interested, just register this course. We'll have a lot of discussion on this and we can give you more insight on it. Anyway, this is a just high level picture as I mentioned. So this is your chip that has been manufactured. So this is the stimuli. Stimuli means ATPG pattern that will be generated as a DFT engineer. This stimula or ATPG pattern will be driven from the tester. So this is your AT test application environment. So it will be driven here. Then the response will be coming out from the chip. It will be compared with a circuitry. It is also already there inside the AT. So AT will do the comparison. If the response is correct, then it will flag as a green, good. If it is the response is bad, then it will flag as a bad response. So this is how the AT actually works. So it can detect which is the faulty defect, which is the fault-free chips. Okay, so now let's get some overview on how the semiconductor ecosystem is actually there. I have already completed some of the technical overview on it. I'm not going to any more details, but I want to give you some overview on how is the job opportunities in the overall semiconductor industry. You can see that we have a lot of company doing a lot of different kind of jobs. We have some kind of design company like IP vendor, ARM, Synopsys, Cadence. They have actually building some kind of IP that will be used in different companies. We have EDA software company, Siemens, EDA, Cadence. Then we have IC design company. You have already heard this name, NVIDIA, which is a very good company, AMD, Qualcomm, Intel. So these are the all product company. They are making the product and they need you. So they will be looking for you. We need a DFT engineers because we are going to make a product and that product definitely needs for some kind of testing features. We also have some IDM. IDM means integrated device manufacturer, those who manufacture the product and they have the fabrication labs also. Intel, Samsung, Infineon, Micron. So they have already a lot of product and the own fabrication lab as well. So the foundry service, Samsung, TSMC, UMCMC, Intel. So there are a lot of foundry. Some of them are very popular, which is the TSMC #1 foundry. And you will have a lot of other companies that are doing a lot of activities. And most of the thing, the key information or key message from here that we have a lot of company that actually waiting for us to give the opportunity to play our role as a DFT engineer, because every product design needs the DFT engineer, must. So since we have a lot of company, that means definitely we have a lot of opportunity, and their salary range and their paying scale is very high. It's a very smart compared to other jobs. So it's a very handsome salary you will be offered if you get opportunity to these companies.
As Ahmed, yeah, can you just highlight the packages, salary packages?
Yeah. Actually, I have that one more slide at the end.
Yeah.
I'll be sharing. I'm coming to that slide. Sure. Okay, so this is another thing that I just wanted to give quickly overview regarding the Intel, TSMC, Global Foundry. So these are all the foundries that actually manufacturing the product. Not every company like NVIDIA, Apple, they don't have any foundry. They just build the product, they design the product, but they send the design to the TSMC to manufacture it. So only few companies are there, they can manufacture the device. These are the top rated company. And I think if you can see, this is the last update from 2022, where the 7 nanometer technology is Intel there. But recently, Intel is going to launch its latest product, which is the Panther Lake, which will be using your 18 angstrom latest technology node, which is a very sophisticated technology node. So day by day they are moving to new technology node, and since the technology node is going to be very smaller, the defect density will also be very higher. So DFT is becoming a very must for the lower technology nodes. So you have to definitely take care of it. Okay, so now I am going to put more summarized information regarding your responsibility as a DFT engineer. Although I have discussed this many times, but these are the key points that you can focus on it. That what are the key skill that you need, what are the career path that you have, and what will be your salary range. So let's start with the key responsibility of your DFT engineers that I already mentioned. That you have to collaborate with the cross-functional team to establish the testability goals and requirement, and then developing and implementing DFT methodology and strategy. So how can you automate the flow? How can you make sure the new requirement for DFT architecture, it can be incorporated? That kind of activity you will be doing with the DFT architect. Designing and integrating test feature into the product architecture, ensuring the use of DFT standard and best practice, conducting testability review and providing recommendation, work closely with the test engineer to optimize test coverage and efficiency. So these are the responsibility and key skill that probably we can focus on it, proficiency and hardware design. So if you have some bachelor's degree, then it should be good enough. That's the minimum requirement, not necessary that you have to get some master's degree, not needed. Programming skill, understanding the industry standard, analytical and problem solving skill. So these are the soft skills, some kind of soft skill that if you have, then you will be very focused on your team that, oh, okay, these people, he has a very good presentation skill, he has a very technical skill, and he has also very presentation skill. He can present the problem, he can discuss with the team, he can guide with the team. So this kind of soft skill will also be very helpful for you. Yes. Okay, for the salary range, so this is something that I just captured. Maybe it will be, it can be a bit more nowadays, because now you know that the salary package they have every year, they will review it. So it's just a comparative salary range that I have captured here. So since you will be joining as a fresher, consider as a 0 to 2 experience, your salary, initial salary range will be something like this, the per year salary range. But you can think of it like you just completed your bachelor, that you don't have that much experience in the industry. But if you complete this training, the way we have designed our module, the way we'll do our training, we'll mock interview, all those labs, looks like after you complete this 4 months course, you can be like a 2 years experience engineer. Because the 2 years experience engineer, the amount of knowledge he has, we will try to put it within 4 months. So you will get a lot of benefit after completing this training session. Definitely you can compare that, okay, I have completed 4 months, but I am equivalent to a 2 years experience engineer. So you can discuss with your employer that I should negotiate with my salaries, all those things. That's the benefit. That's the way we have designed our training modules. So definitely it will give you very earlier exposure of a very good salary range. And career path, definitely, as I already mentioned, that your job is not about is pre-silicon. It also involves the post-silicon. So you will have a good opportunity to either explore the design side, or if you feel interested, okay, I want to explore the post-silicon side also. I feel better interest to debug the silicon, all those AT. So you can choose either DFT engineer or test engineer. So you have a long scope of your career path. So you can switch off. Okay, I first for few years I work in a company as a DFT engineer to explore the design phase, how it looks like. Then I switch another company, join as a test engineer to see how the DFT architecture they bring up on silicon, so I can gather more experience. So the amount of exposure you will have in your career, the more secure your job will be there, because the industry, all those people, they are looking for um, uh, diverse scope of their working skill. So the more skill that you said you have, the more secure your job will be, the higher the demandable your job will be there. So I think that's all that about I wanted to discuss and share with you. So if you have any question, please feel free to ask me. I will be happy to provide
Yeah,
clarification.
let us take them through this curriculum, right?
Oh, sure, sure. Yeah, I think I have open up that one. Just give me a second. I pick up my slides there. Okay, so we have already designed our curriculum into multiple modules. So this modules has been designed basically to train up you step by step to make sure you have a very basic understanding. Then on top of it, you add more information so that your base is very strong. That is what actually we want to focus. Because if the base is not very strong, then you will not feel very confident to work on the real project. So that's why we design our modules with the basic digital electronics. Then we'll be discussing about our Verilog coding, which is equivalent to RTL design. Then once you are get familiar with all those things, then we will start our introduction and basic of the DFT, where we'll have a lot of contents that will give you more insight that how the DFT works actually happen, what are the things that you need to know. Then what will be our scan insertion? Just now I show you one slide, right? There is a lot of discussion that we have incorporated here to make sure you have a very clear understanding for each of the topics and you can become a very good DFT engineer. And then we'll discuss some of the advanced topics, which is the scan compression, which is a very required skill set to make sure you are generating very optimized test pattern. Your scan architecture is very optimized, and all the latest compression features that we have in our industry, you will get familiar with this topic. So we cover all the necessary topics here. And we'll also be covering ATPG part. After completing the scan insertion, you will be doing the ATPG, which is the pattern generation. So how the pattern has to be generated, how the pattern has to be verified, all the verification method we'll be discussing in detail. And then we'll discuss about the on-chip clock controller, which is a very advanced topic. And then we'll have some more discussion about the simulation, how to verify the ATPG patterns, and what are the scenario that can happen to debug. This kind of manual debug we'll try to give you some more insight. And then we'll have the MBIST, which is these are all the advanced topic, but we'll still give you some more insight. MBIST, boundary scan, logic based diagrams, everything. So the important thing is that every module we will have some kind of, after completing every module, probably we'll take some mock interview to make sure you have proper understanding before we proceed to the next module. And at the same time, for every module, we have some kind of lab to make sure whatever you have learned, you have practiced it so that that can go inside your memory and it can forever last. So that's how we have been practicing for the previous batch, and we'll be continuing it. And if you can cooperate it, if you can become more interactive, we'll try to make the session more interactive to make sure you are very comfortable to learn and practice all those things. So this is all about our training modules.
Thank you,
So
Ahmed Bhai. So guys, first is this really this training and placement is going to be help you people to kickstart your career in the booming VLSI industry. Okay, with the good packages, as we told, right, we have people who got paid for minimum 4 lakhs to more than 8 to 11 lakhs as well. Okay, but it totally depends. Placement part is totally depends upon the market requirement and the company part. Okay, but as we told, we are there to help you till you get placed. Okay, so as we told it, so our DFT new training batch is going to start from 20th of this month, October. So as I already told you, we already got like an 8 to 10 registrations and we have very less seats available. So whoever is interested, please make sure to connect up with our operations or sales team and do the registration. Okay, so before moving to Q&A, so I would like to just present, showcase our recent placement people. Hope my screen is visible to everyone. Okay, so these are people who have placed very recently with us. So in PD and DFT. So we, as we told you, we even now currently still we are waiting for a couple of more interview updates from the Wipro and Insemi, and we have also we have from the Insights Infotech, and we are in touch with couple of more broad-based companies as well. So these are our recent placements, which includes PD, DFT, and as we told, we have our NSME as service company. So placements can happen with our own company itself. Okay. So if you wanted to talk to any of our place people, please connect up with our HR. They'll be able to provide the contact details of the people who got placed so that we can talk to them in person. So let us move to
Excuse me. What are the product-based companies got hired? Like in
see.
which are the
Let me
product-based?
tell you clearly, Nikhila. So product-based companies, to be frank, we don't give any assurance. Okay,
Okay. Okay.
and and also what we would suggest, right? Let everyone start the career with the service based companies where you can get more knowledge, where you can work the multiple okay. So what we suggest people, let everyone start the career with a service based company and work for minimum 1 or 2 years, then move the product based company. Yes, and you will get directly product based company. Yes, we will able to help them with the product based companies also. We have people who got placed in multiple product based companies also.
Okay.
Okay. So as I told you, right? So we are going to start our new DFT training batch from this 20th. So we almost complete 8 to 10 registrations. So we have less seats available. Okay. So please ensure to make the registration priority. Any other queries? If not, we can find. I think there is a query in the this one chat box. By name Valli Shri. She asked. They asking some. Yes. Check
Okay.
once.
In the first slide, it was mentioned the datasheet is generated after the post-silicon validation, but for validation itself, the data, right? Can you clarify whether it is final update data? Okay, just give me a second. I just double check my.
Yes, as I told, this training is going to purely online, and we are going to start a batch on 20th. Okay, please make sure to do the registrations on priority by paying the 10K as a registration fee.
That is, yeah, I think Sri, the question that you asked, if I understand it correctly, regarding the data sheet. So basically, the data sheet is finalized based on the final silicon characteristics. Initially, there will be a product specification document that is initially released when the product architecture starts to happen. But whether the design is actually performing with that particular voltage, frequency, and all other characteristics that has been committed, it can only be validated after the silicon comes. So after the silicon comes, they validate all kind of silicon, make sure what is the operating voltage, what is the operating condition. Based on that, they can do their final datasheet preparation. So that will be the final datasheet that will be released when the product actually been released to the customer. I hope this answer your questions.
Yeah. Thanks.
Okay.
One more question was there from Nagaraja.
Okay, Nagaraja, after scan chain reordering, this pattern is going to change? Yes. After scan chain reordering, the test pattern will change because the test pattern will based on the scan chain order, the way the scan chain actually been organized. So during the physical implementation, in order to complete their physical timing verification, the physical design team, they do some kind of scan chain reordering. But it should be fine. The tool actually, it doesn't make any difficulty for us to generate the pattern. It just that the flip-flop has been changed their order. That's why we have to regenerate our pattern. That's why before, I mean, as a DFT engineer, the final pattern generation happen based on the tape-in netlist. Because before the tape-in netlist, they will have a multiple iteration to close the timing. That's why they will have a multiple iteration. Every time the netlist will change, but it should be fine because we know that netlist change can change, reorder change, but it doesn't add complexity for us from the DFT perspective. That's why we just wait for the final tape-in netlist. Once the tape-in netlist comes, we generate the pattern, and that pattern is going to run on silicon. Okay. Nagaraju, is this clear? Okay.
So, so guys, so along with this, as we told, right, we along with the VLSA, we are providing our uh, uh, IT trainings as well. So we just want to take up you guys through these. Yeah, these are on-job. I hope my screen is visible to everyone. So for our on-job IT enable program, so we would request your friends to be refer your friends, where we cover. Akhil, you're there?
Yes, I'm there.
Yeah, yeah.
Okay. Hey, hi. Thank you for this. Hi, guys. This is Akhil Ahmed here. Total 15 plus years of experience in the IT industry. I was in Brunei, Malaysia, and US and Canada. Coming to this on-job IT enabled program, my first priority is I suggest all my teammates, colleagues, like first of all, give the priority for whatever your education branches are. For example, if you are from a ECAE or Triple E background, I would recommend please go ahead with DFT or PD trainings. But if you are from computer science background or IT background, you should always prefer for a software industry. This is the suggestion I give. So what happens is, many of the EC students try to jump into an IT industry, and even after 10 years of experience, just because your education is from EC background, you will have the problems. And same happens with computer science students who are from CS background and try to get into VLSI industry, even they will face these challenges. So always my suggestion to you people is always prefer whatever your education background is for your job. This will have a good impact for your profile for your long-term career, whether you have to move to US, UK, Canada, or any part of the world in the future. So just choose the choose the jobs which matches you with your education. So that's the first step. So coming to this on-job IT enable program, you may have see these terminologies, and I know most of the people, whether you are from whichever background you are, you would somewhere would have heard these concepts, whether Windows administration, Linux administration, VMware administration, uh, AWS, Azure. This is something very common terms now. And what differentiates Success Bridge from any other training program is what we are going to do here is we have created an existing customer whom we support. So irrespective of any IT industry, wherever you get into a job, what they are going to do is first they are going to give you a laptop and an ID card, and they will make you some XYZ company sample. Once that is done, they will make you work to a different customer. And here also in this on-job program, what we are going to do is we have created a similar infrastructure which is spread in all these technologies, whether it's AWS or Azure. So we have procured some servers in Azure, some servers in AWS, and we have hired some on-premise infrastructure as well. So whoever enrolls in on-job IT enable program, from day one, the training is like 3 to 4 days. The trainer will teach you, and 3 to 4 days he will make you work on that. So with this, what happens is whether if you are a freshly graduate, you will get to know what exactly I will be doing in my 9 hours of job when I go to an IT company. So what we are doing here is first 1.5 month we will train you, and then we'll start building your resumes, telling that this guy has an exposure to real time work. He's not an any educational background guy. So this helps for freshers. And second crowd which we are targeting here is people who are willing to switch their careers. For example, you did a BTech industry, you joined a BTech industry. Sorry, you graduated from BTech, and for some reason you got into a job which is not of your field. Now you are planning to move to technical. So this plays a very important role. I mean, this program can help you a lot. And unlike DFT and VLSI, which Ahmed just explained, this is a subscription based. So, like the placement Yusuf did not highlight here, and I had to join remotely without proper presentation. I'm so sorry for that. We had a person who got placed in Infosys last month, and we have recently one candidate who received an offer from Genpact. So there are a lot of placements happening in on-job IT enable program as well. So this is one other program which we are running. So maybe most of the people who are here may not qualify for this, but I'm sure there are many of your friends, colleagues who are looking for a job, who are from IT, educational background, or people not happy with their job, wanted to switch their career. You can definitely refer it to this, and we are allowing like 1 to 2 sessions, free of sessions. And one good advantage of this is they don't have to be physically present in any of the Bangalore or any of the metropolitan cities. They can join from anywhere, just like how company gives you virtual desktop. So we have students from Malaysia also joining this, getting to know how to work in an IT industry and getting the jobs there. So this is the like a regular program for almost like the batches are being done every 15 days. We have a new batch which is starting. So if you come across any people, please feel free to refer us. So probably if anyone needs it, you can reach out. Our operation teams will share you all the details with this. With this, I think I won't take much of the time. I think I'm good. If you have any questions, you can reach out or you got here.
Yeah, thank you. Okay.
Thank you.
Okay. So guys, as we told, our VLSI or IT infrastructure trainings are purely based upon the work of sharing the technical part and the placement sessions as well. So yeah. So there is one more question Nikhila is asking here.
Yeah. So Nikhila, for your question, actually, I would say that AI is not going to replace our design engineering job. Because if you think of that, AI is something like this, it will do more automation on the design tools that we are actually using. That means over the time, the tools will becoming more smart. And definitely those people who are going to depend on the tool itself, they have a risk to be replaced by the tools. Because let's say from the physical design perspective, they use a lot of tools. But if the tool is smart enough, then definitely they will need less people to run those tools. But let's say if you think of our DFT engineering perspective, DFT has a lot of manual work for validation. Like when you are doing for simulation debug, simulation is something like it needs a human to interpret the result to make the next steps. So that kind of things, DFT has a lot of things that the engineer has to do a lot of manual job. So AI is not going to actually making that much impact from the DFT engineers. I would say our jobs is more secure compared to the others where the AI can actually be a threat. Yeah, then that tool is outdated. I don't think so, because the tool definitely needs to be there to help us to do the pattern generation, all those things, because it's not something that we can do by ourselves. But the tool will getting smart day by day, because even the tools vendors, they are trying to incorporate into the AI so that their tool become more smart, and definitely that is needed. So everyone wants more automation. So it's okay that tool become more smart with the help of AI, but I think as a DFT engineer, you have a lot of scope for manual activity to showcase your capabilities. Those kind of things, the AI is not going to be replaced.
Yeah.
I hope it answered your question.
Yes, yes. See, because in semiconductor industry, right, is manual intervention is pretty much required for the chip accuracy and multiple things. So I don't think it will impact semiconductor jobs like compared to other industry, other domains.
Okay, what about test engineers? Can AI will impact? Yeah, I think for the test engineers, definitely they are trying to incorporate the AI to develop some kind of automatic test program development. But I have been doing that test engineering job for few years. But what I think that in the test engineering job, they have to interpret a lot of data. Maybe the AI can help to analyze those kind of data, but there has to be some engineers to make the decision. What should be the issue? Those kind of things actually involve a lot of kind of manual work. Right now, the amount of manual work is very huge. With the incorporation of AI, maybe it will be become more automated. But I think the skilled people definitely they are going to be stay there because they are not going to replace. It's a very less. I would not say that it's not impacting. It will impact, but definitely the impact will be very minimal. That's why I would say during our training session, even I will say that whatever you are doing, there are few steps or there are a lot of things that you have to do some kind of manual work. And that kind of thing, usually many people I have seen that they are not interested because it's a manual work. They look for more automation because automation makes the life easier. They don't have to put that much, just run the flow. That kind of people are in risk, definitely. In this industry, you always have the passion to learn more things. You have to always adapt those things that can make your job more secure. So definitely we have a lot of scope that if we can adopt this, they have a very high demand and not AI is going to replace that very soon. So you can secure your job very well.
Thank you, Ahmed. So guys, I think we are running out of time. So if there is no concerns, we can wind up. So as we told, right, I just want to reiterate, we have VLSI plus IT infrastructure training, which are going to start from next week. So whoever is interested to start their career there, either in VLSI or IT infrastructure, please reach out to our sales team or operations team. As we told, our DFT training will start from 20th of October. So we have very less seats available. As we have, see, as we told, right, first impression is best impression. So hope you people had a good demo session. The demo session itself give us then clear information how our training session is going to be, how our trainer is, how our placement process is going to be happen, how what are tools we are using. Everything has been given it to you guys. So this can give the clear information how the training is going to be impact your technical skills, how it's going to be upskill yourself. So this is what I would like to say. If you don't have any queries, we can wind up. As I told you, right? So please connect up with our people or marketing team and complete registrations on priority. So guys, let us wind up the session. So on behalf of our Success Beach, I would like to extreme uh, heartfelt gratitude to our active participation in the demo session. Okay, we hope the demo session has provided you the valuable insight to the training program, what you're going to offer either in VLSI or on-job IT-enabled program. So it was pleasure to you to showcase our curriculum, the methodologies, and the learning environment in Success which we basically create. And also your thoughtful questions. I'm really, specifically with the Nikila and Walli and couple of people who have asked their questions. I'm really happy for them, which makes them our demonstration much more interactive. Thanks to everyone. So though we understand your time is valuable and we are very grateful to have you choose to invest with us for today's time. Okay, once again, thank you for your participation, everyone, and for being an integral part of our training demo session. So we look forward to welcoming you for our full-time training programs. Okay, so please do registrations on priority and take step towards your starting your career in the VLS industry. Okay, thank you. Thanks, everyone.
Okay, bye.
Thank you.